Okay, so this week we're going to work with chapter 2. My hope is that we could get through all the slides today, but if we can't, then we can obviously pick up on Wednesday with whatever we have left remaining. Chapter 2 deals with how we organize data. So it's a little bit more like your traditional what you think of when you think of stats. We're going to talk about frequencies, distributions, histograms, and topics related to those. So our focus points for this set of slides, we're going to organize raw data using a frequency table. You guys will learn how to construct histograms, relative frequency histograms, and ogives. It's just interestingly named, but it's not that difficult. Pay attention to these kind of things, because if you guys want to do that M&M / whatever healthy food you want to go with there, or I guess assorted candies activity, this is the stuff you're going to be working with. Okay. So it replaces the exam for 4 and 5, but it kind of is a nice activity that lets us do a lot of things that we've already done. Okay. We're going to recognize basic distribution shapes, so uniform, symmetric, skewed, and bimodal, and then interpret graphs in the context of data setting. So frequency tables. If you are someone who needs to take handwritten notes and you like to write down our definitions and that kind of jazz, a frequency table is data that's split up into classes or intervals and shows how many data values are in each class. The classes or intervals are constructed so that each data value falls into exactly one class. So I'm sure even at this point, you guys know that a junior can take classes typically that are for juniors. But we all know that when you're in high school, sometimes you have freshmen and sophomores who can end up in your junior class, or sometimes a junior is in a freshman and sophomore class in terms of like what the actual course is. So in that kind of case, typically you're not going to want to go with freshman, sophomore, junior, senior, because you could have a class that has all of them, if that makes sense. Like these frequency tables will only have you in one class. That's it. You're only going to be found within one boundary. So a really good example of these is a lot of times they use age ranges. So obviously if you're 18, you're not also going to be counted in the 20 to 25 slot. You're only 18. Okay. So that's what we mean by you're only going to fall into it exactly one time. So here's an example that we can work through. It says a task force to encourage carpooling did a study of one-way commuting distances for workers in downtown Dallas. A random sample of 60 of these workers was taken, and the commuting distances of the workers in the sample are given in table 2.1. Make a frequency table for the data. So it's up to you guys. We can either take the time and you could write all of this down, or I can just kind of talk you through it. You can also come back to it in the YouTube video and work through it as well, because I don't think we'll have time for you guys to memorize the table, like the answer table. So it says, first decide how many classes you want. 5 to 15 classes are usually used. If you use fewer than 5 classes, you risk losing too much information. So that's kind of meaning if you have a large amount of data and you only want to separate it out into like say 3 categories or three classes or bounds, you're going to have a lot of data in each class. So it's going to look like everything is just kind of chalked up and in the middle, and there's not any real differences. So the more classes you have, typically the better you're going to be presenting your information. So we want to spread the data, and the purpose of the frequency table by these guidelines in selecting the number of classes. So for our case, for this situation, they're going to use 6 classes. It says next find the class width for these classes. What do you guys think the width is? Or what do you think it could be? Not specifically related to this example, but if you were to take a stab using context clues as to what the class width might be, what do you think that could be? So if we consider
like the range.
Yeah. Okay. So just like with any other class, a width, you know, is from where you start something to where you end something. So yes, your range. In my example with ages, you know, you could have 18 and under, you could have 12 to 16, you know, whatever your situation is. So this is something you all want to take note of. This is how we find class width when we're given basically just a bunch of numbers. So in order to compute it, you take the largest data value minus the smallest data value, and you divide it by the number of classes. The only difference for this and your definition for range is that you would take your largest data value minus your smaller data value, and that's it. You don't divide by anything. So yes, you're essentially taking your range and dividing it by the number of classes. So then you'll find smaller, more useful ranges. And then we increase the computed value to the next whole number. So you always want to round up, even if, let's say, your decimal is just 0.1, you're always going to round up. Okay. So it's like the one time where the 0.5 rule doesn't really matter because we can't have a tenth of a person. So you're just going to round up all the time. All right. So that is definitely going to be on your exam. We'll talk about that a little bit more on Wednesday, unless I have time at the end of today's session. Okay, so to find the class width for the commuting data, we observe that the largest distance commuted is 47 and that the smallest is 1. So obviously that person, if they're living in Dallas, Texas, with the exception of like the dead middle of summer, they should be walking to work every day. I don't even know why they need a commuter distance because that's absurd. Okay. It's not like they're up here where we get like 20 inches of snow. All right. So 47 minus 1 obviously would give you 46 divided by the 6. We get 7.7 and we're going to raise it to 8. I believe that says increase to 8 and they just cut it off. So I don't, Reese to me is not a word. It's not a shortened math word, even though math people don't really like words. So if we came back to the table, all you guys would do is you would look through and you would try to find your highest one, which they made it nice. It's right here. But of course, you can't just go to 47 and then assume that's your highest number. You actually do have to take a look. If they messed up, you would want to do it correctly. And then 1, of course, 1 will probably more than likely always be your lowest number unless the situation, whatever the application is, if the application allows for negative numbers, then you want to make sure that you're taking that into consideration. Yes.
Wait, so going back to the table, is the number of classes like how many rows there are, or is it each individual number?
The number of classes will, so if you're constructing a table and the question is from WebAssign, WebAssign will normally tell you how many classes it wants. In this situation, you kind of have control. So they gave you the suggestion to do 6 classes. as long as you do classes between 5 and 15, you're going to have enough data material. So it's kind of based on you and what you want, unless the problem tells you. Does that make sense?
Yeah. So the table, like, it has nothing to do with what's on the table.
No. So the only thing it has to do with what's on the table is how you compute the class width. So you'll have to go back to the table and find the largest value and the smallest value. But like how this has 1, 2, 3, 4, 5, 6 rows, that's just a coincidence. Like it could have been reformatted to have only 5 rows and they still might have used 6 as their class width. Okay. So you don't have to count the columns and you don't have to count the rows to figure out the class width. That's just what they chose to do. Like they just chose to use the number 6. And I would assume that this is a coincidence. In fact, they probably wish they wouldn't have done that, because now some people might assume that's what you have to do. You don't have to do it that way. What you do have to do, especially for WebAssign guys, so like I'm more lenient, obviously. I'm a human being. I have degrees in mathematics. When you give me something, I know how to read it. WebAssign is a program and it was built by programmers. So if it says use 6 classes or use however many classes, that's what you have to use. Okay. Now, if it lets you pick, and you just have to identify, then you can do it the way you want. Okay. So yeah, the desired number of classes does not equal anything. It just has to be between 5 and 15. All right. The lower class limit is the lower data value that can fit in the class. So in my example where I said 12 to 16-year-olds, 12 is the lower class limit and 16 is the upper class limit. The upper class limit is the highest data value that can fit in that class. The class width is the difference between the lower limit and the upper limit. The lower limit of one class and the lower limit of the next class. Sorry. I misspoke there. Okay. All right, so the smallest commuting distance in our sample is 1 mile. If we use the smallest data value as the lower class limit of the first class, since the class width is 8, we add 8 to 1 to find the lower class limit of the second class. Following this pattern, we establish all lower class limits. Then we fill in the upper limits so that the classes span the entire range of data. So this is what your tables will look like when you make your own. No matter what the data is, you will have class limits, lower and upper, class boundaries. You'll have tally marks. Sometimes the tally marks aren't done in the WebAssign, but if you do them by hand, so in your one activity, you will do the tally marks if you wish. If you don't want to, you don't have to. It helps with the frequency. So if you do all your work in Excel or in Google Sheets, I can show you there are ways to do this without getting confused. And then you also have to have your class midpoint. All this information is important when you're constructing the frequency table. Okay. So 1 to 8, 1 is their lower bound for the first class, 8 is their upper bound. Now you have to include the numbers. So if you count 1 to 8, you don't have 8 numbers, you actually have 7. 2, 3, 4, 5, 6, 7, 8. I lied. 8. Wow. And then each time you do that, you'll have 8. But then to get to this next lower bound, they took the upper and the lower and added it together. That's one way of doing it. Honestly, I just figure out my classes like by adding naturally. So if you have 1 to 8, you know that the next class will start with what? 9. Now you can use their technique of doing 1 plus 8 is 9, but I mean, I just write it. However you guys see it is how you see it. I don't do it the way they said to. Now, take a look at the class boundaries. Notice that they have a 0.5 below and a 0.5 above. Okay? That's because if we were to deal with an application that would have something that falls between those ranges, it's showing you where you'll put them. Okay? So something that's 0.75 will fall between 8.5 and 16.5. So it falls in the 9 to 16 category. Does that make sense? Okay. Once you have all of your data points kind of put into where they belong, then you can go through and either do your tallies or your frequencies. I believe the point of the tallies is if you're not going to actually physically put the data points into some kind of more organized table. Like if you're just going to look at the original data table that they gave you and pull out your information, then you're going to want to use the tallies. Okay. Me, I rearrange mine. And I typically rearrange almost all data sets that I'm given to be numerically making sense, like, least to greatest, unless I'm given like so many data points that I cannot physically do that. I use Google Sheets a lot, and that's my suggestion to you as well. We can have a session if you guys want. I don't know if it can be like during our regular class time, but if you want like a recitation session where we go over some Excel, Google Sheets or Excel information, we can definitely do that. I just don't know if we can squeeze it into our actual class time. All right. So now that we are ready to tally the commuting distances into the 6 classes and find the frequency for each class, this is talking to you about how you tally. So it's a method for counting data values that fall into a particular class or category. I'm assuming most of you are aware of what tally marks are and how you use them. Okay. Please tell me this is still something that is at least being touched on in our education system. Okay, great. At least not all things are lost from Greeks and Romans. The class frequency for the class is the number of tally marks corresponding to that class. So if we go back, 14 is the class frequency for the 1 to 8 class or class 1, okay? Because that's how many data points fell within there. Okay. The center of each class is called the midpoint. So the midpoint is often used as a value to represent the entire class. Okay, the midpoint is found by adding the lower and upper bounds together and dividing it by 2. In other words, what did they find there? They found a midpoint. But what else can it be called? Or could it be thought of? You can kind of...
Isn't it called like the mean or...
Right, so you can kind of think of it loosely as a mean or an average. The reason why it is not a true mean or average is because you have 14 data points that fall within that range. So to find the true class mean or average, you'd have to add up all 14 of those and divide them by 14. But if you think that adding the class limits up and dividing it by 2, if you think of it loosely like that, then you'll probably remember it better. But yes, excellent. Great job. Okay. There is a space between the upper limit of one class and the lower limit of the next class. The halfway points of these intervals are called the class boundaries. That's what we discussed earlier. You find them by adding 0.5 to the upper limit or subtracting 0.5 to the lower limits. And again, those are for when you are dealing with an application where you might have decimal points. Okay, you want to know which class do I put this in. Those decimals values will help you figure that out. I will tell you that you will never come across, if you've constructed your table correctly, you will never come across a situation where you don't know where to put a data point. It will not belong in two places. So if you think it does, then something messed up with your classes. So you'll have to, it's kind of a really nice internal way of checking that you're doing something at least what should be considered correct, because as long as each point goes in only one place, you've pretty much have completed a frequency table. It'll just be like, for me, I'm probably going to give you all the points and I'll just say, you know, you used the wrong class width or whatever. WebAssign will ding you if you mess it up in any regard. Okay, so basic frequency tables show how many data values fall into each class. The reason why we like to know this is because then we can find relative frequency of that class. So that basically means that once we can find this category right here, this relative frequency, that statistic is really nice because it's basically telling you the probability of somebody falling within those ranges. Okay. So this is why we do the whole table right here, this relative frequency. So you could get a relative frequency just by counting things out, but I mean, you're basically making a frequency table anyway, so you might as well just make it organized. Okay. Do you guys have any questions on up to that point? Okay. You will have to do frequency tables in your homework. So if you end up doing your homework and you find out that you keep messing that part up, either watch the video that should be related to them, or, I mean, there's always YouTube. If you can't really find one that you like, you can always email me and I can send you one. It's really amusing. Sometimes students email me and I don't think they expect me to send back a YouTube video, because obviously you guys have just as much access to YouTube as I do. But sometimes students just want it sent. So I don't mind. It doesn't bother me. All right. Okay. Oh, no. It's not what I wanted to do. Stop. Okay, so relative frequency is the class frequency divided by the total of all frequencies. So if you take a look back here, they're doing 14 divided by 60. You don't want to come into the situation where you think you have to do 14 and divide it by the total in the class. If you do that, you're obviously going to get one out every single time. And if you start seeing that, then you've done something wrong. Okay. I don't know why they showed us the table again, but you know, I guess maybe so we can see that. Okay. I don't know why they're showing us that either. Okay, so the sample size is 60. Notice that the sample size is the total of all the frequencies. Therefore, the relative frequency for the first class, which is the class from 1 to 8, is 14 divided by 60, which is roughly 0.23. All right. Always use approximate, this squiggly equal sign. So never use an equal sign when you're talking about probabilities. Okay. Relative frequency will be something you'll be asked about, so definitely know how to do it. The total of the relative frequencies will and should always be equal to 1. So if we come back here, if you take 0.23 plus 0.35 plus 0.18 plus 0.10 plus 0.07 plus 0.07, you should get 1. Not only that, but if you take all these frequencies and add them up, you should get how many? Don't say 1.
60.
Yes. You should get equal to the n, okay, to your sample size. Excellent. Okay. Rounded results might give you a little bit more or a little bit less than 1. So something that, you know, if you're someone like me whose brain, for whatever reason, can't really tell you, I see a lot of things. Granted, it depends on the situation, but I see a lot of things that black and white. So if you tell me that the answer should be 1, then to me, 0.999999 is not equal to 1. Don't get yourself in that kind of situation. If it's a little bit more, and I'm meaning a little bit more, so 1.000 whatever, or 1.1, anywhere in that kind of ranging, you'll be fine. But obviously, if it's 1.5, you've done something wrong. Most of the time, they should equal around 1. Okay. This is the entire procedure on how to make a frequency table in terms of wording. So if you want to snippet that or screenshot it, however you want to do it, write it down. These are the steps that you will follow to make your own frequency table. You want to determine the number of classes and the corresponding class width. Again, that part can either be given to you, or you'll have to kind of, if they leave it open-ended, just know that the number of classes will be between 5 and 15. Create the distinct classes, all right? Lower limit, upper limit. Fill in the upper limits. Tally the data into the classes. Find the class frequencies. Compute the midpoint, and then determine the class boundaries. Midpoint, for me, you only will have to probably do that once. Well, most of our exams are on WebAssign. I mean, it's not hard to do, but I'm just not going to be that picky about the midpoint on your activity. So as long as you do it one time on your activity, if it's something you don't really want to do every time, that's fine. You don't have to. All right. Oh boy. It kind of stuck, so I thought it was done. Okay. Relative frequency table, it's literally the same exact thing, except then you have to compute a column for relative frequency, which is F over N. All right, F is the class frequency, N is the total in the sample size. I don't know why they choose to reiterate some things, but I guess they do. All right, histograms and relative frequency histograms. Does anyone know what a histogram is? It is a type of bar graph, okay? Histograms and relative frequency histograms provide effective visual displays of data organized into frequency tables. So histograms are like, let's say you're not a mathy person, you are not enrolled in this class, and you're enrolled in some other class where they're like, find a way to display your data. Histograms and bar graphs are the one thing that the majority of people remember. So even if it's not the best data tool to use, that's what they end up using. My mom teaches nursing classes, and she constantly gets students that show their data as a bar graph, and she constantly has to email me them and say, are they doing what they should be doing here? And I often ask if they've had a stats class. So sometimes pie charts are a lot better. You guys will be learning about all of them. Okay, so how to make a histogram or a relative frequency histogram. So we have to first make the frequency table. That's why we learned about it first. Place the class boundaries on the horizontal axis and the frequencies or the relative frequencies on the vertical. For each class frequency table, draw a bar whose width extends between the corresponding class boundaries. For histograms, the height of each bar corresponds to the class frequency. And then for relative frequency, it's corresponds to the class relative frequency. So basically, once you create the frequency table, going to the histogram is not that hard. It's one extra step. Okay, you're just basically drawing what you've already determined. So again, they're going to give us the commuters to the downtown Dallas area. They're just re-giving us the table. And then here you'll see that they did the frequency table or frequency histogram based on the frequency table and the relative frequency based on that extra column. Okay. Do you guys see how easy it is to go from the table to the bar graph? WebAssign will sometimes make you construct your own. Most of the time, they'll just have you select the correct option. Any questions on the histograms? You will want to use histograms when you want to convey a little bit deeper of a meaning with your data, as well as people who don't like math, they don't really like numbers. So if you're going to give them a table, they'd much rather see something like this that they can kind of maybe understand a little bit more. They just really like images. That's where it comes down to. But you obviously need to make sure you construct it correctly. Okay, for each class of the frequency table, make a corresponding bar with the horizontal width extending from the lower bound to the upper bound. The height of the bar will correspond to the frequency. Notice that the basic shapes of the graphs are the same. The only difference involves the vertical axis. The vertical axis of a histogram shows frequencies. Okay, that makes sense. All right. Distribution shapes. So histograms can be valuable and useful. If the raw data came from a random sample of a population, the histogram constructed from the sample values should have a distribution shape that is reasonably similar to that of the population. So that kind of means like if we did this same study and the researcher decided to poll like senior citizen homes, obviously no one's driving anywhere. And if they are, it's probably not that far and they probably won't be doing it for that much longer. Okay. So, okay. Here's what's important about the shapes. A mound-shaped symmetrical, okay, this is going to be where you tend to have a higher middle ground and then all the rest kind of nicely. It's like you walked up the stairs to stand on first place and then you walked back down the stairs. Okay. You have uniform or rectangular, which just basically means that the whole thing looks like a square, like everybody's happy. Everybody's in the middle. You can have skewed to the left or skewed to the right. Skewed left and skewed right, I will tell you right now, if you have trouble with them, do not get frustrated. I know you'll get frustrated. I've been there. I'm super, super dyslexic, so I would get these wrong all the time. So to help you, I will tell you that it deals with the side of the tail. So if you think about it, if you're pinching the data and the side that pinches closer to the axis, that's where the direction is skewed. I know it sounds ridiculous and backwards. Trust me, I've been there. But that is how we work it. So if you kind of turn the histogram into a dinosaur, you want to go with the tail. Okay. So if it's skewed to the left, the dinosaur's tail will be off and to the left. If it's skewed to the right, the dinosaur's tail will be off and to the right. I'm not going to try and confuse you any more than I have by explaining to you how I saw that differently. I mean, if you really care about it, you can come to office hours and I can express my frustrations with you. but I just don't want to be a cause for frustration for you. So bimodal, much like the way it sounds and should kind of give you a hint, that just means that instead of having a uniform or mound shape where you're looking at just one, you actually have it twice. So you'll have basically two peaks. That is bimodal. Okay, so we have some nice images here to kind of help us out. You can see the mound, how again, you're walking up the stairs, you stand on the first place podium and you walk back down the stairs. Uniform or rectangular, like I said, everybody is getting to the same, it's just working out that way. Here you can see skewed to the left. If you kind of turn it into a dinosaur, you can see that the tail is to the left. Same thing with skewed to the right. And then this is their example of a bimodal. There are better ones out there, but you can see that there's one peak and there's a second peak. Okay? All right, good. If you have any questions on those ones, just let me know. I will gladly answer them. What I can tell you for that kind of stuff is it's just better to just practice. Just go through the homework. If you need help with it, just email me or stop in office hours and we can go through it together. But that's going to be the best thing for you guys to do. Make your note cards, make your flashcards, take your notes however you're going to do it, and then just practice. All right. The cumulative frequency for a class is the sum of frequencies for that class and all previous classes. Okay, so I'm sure they're going to bring back the other table, but in case they don't, I'll go backwards to it. An ogive is a graph that displays cumulative frequencies. Okay, so again, blah, 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 same thing we've just done. And then the only difference is the cumulative. So since they didn't show it to us, we will come back here. Right here in this part of your table, I guess we'll go to the big one. See how we have the frequency here? The next thing you would squeeze in would be relative frequency. And then after that is cumulative frequency. So to get cumulative, you take 14. So this is going to be 14. And then the next one will be 14 plus 21. So that will be 35. Okay. 14, 21, and 11. Okay. You're adding them up as you go. By the end, you should have your sample space. Okay. All right, let's take a quick look at this example. Aspen, Colorado is a wonderful world. Wow. It's so famous. I can't say that it's known all over the world. It's just wonderful, apparently. I've never been there. Okay. If the daily high temperature is 40 degrees Fahrenheit, the surface of the snow tends to melt. It then freezes again at night. This can result in a snow crust that is icy. It also can increase avalanche danger. Okay. So the table gives daily high temperatures in Aspen during a 151-day ski season. Okay. We have our lower and we have our upper. Those are our boundaries because we have 0.5s, right? It would not be considered our class lower and upper because classes do not have the 0.5. Okay. They're using the 0.5 here probably because they know that temperatures can actually come in decimals. So you want to make sure that you're not going to mess that up. Okay. So given the table that they provided, guess they haven't shown it to you. It's 2-11, so it must be in the textbook. They figured out their frequencies. Once they figured out their frequencies, they then figured out their cumulative frequencies. And here they're kind of nice and they're showing you how they found it. Okay. If you need to do that for yourselves, you can do that. I will not judge you at all if you turn in a cumulative frequency table that has these little notes next to it. Does not bother me at all. The only thing I will say is that if you turn that in and that's your scratch work, great. If you're doing it for your activity, you might want to have scratch work and then also have a page that you're turning in for your activity, okay? Kind of just polish it up a little bit. Okay, so the first thing they wanted you to do was make the table, which they showed you they already did. The second thing they want you to do is draw the ogive, okay? So I may have had those out of order. No, I didn't. They shouldn't have had it in that order. Okay, so do you see how the ogive is basically playing connect the dots? Okay. Some students in the past have had trouble doing this. What I typically tell them is if you draw your regular cumulative histogram, you can then just realize that you put the dot in the middle at the midpoint of each class and then just erase the little boxes. I don't know. Sometimes that helps students, sometimes it doesn't. It just depends on how you see it. Me, I can see the connecting the dots. Okay. Again, the best thing for you guys is going to be just to practice. All right, so the solution says the red line on the ogive in figure 2.9, we see that 117 days have had high temperature of no more than 40 degrees. Okay. All right. Any questions on 2.1? Okay, good. If you have any questions on that, you can either ask me at the end or you can email me your questions. We'll go ahead and move into section 2.2. We'll talk about bar graphs, circle graphs, and time series. If we don't finish, then we will pick up where we leave off, obviously. Okay, so we want to determine types of graph appropriate for each data, construct them, and then interpret information. Okay, histograms provide a useful visual display for distribution data. However, the data has to be quantitative. So in this section, we're also going to be able to give you an idea of what you can use for qualitative data. So bar graphs. Bars can be vertical or horizontal. Bars are often uniform in width and uniformly shaped. The lengths of the bars represent values of the variable being displayed, the frequency of occurrence, and the percentage of the occurrence. The same measurement scale is used for the length of each bar. Okay. Basically, all that stuff is telling you is you're clearly not going to have a bar chart and then have different scales on it. It doesn't work like that. Okay. The graph is well annotated with title, labels for each bar, and vertical scale or actual value for the length of each bar. Okay. So take a look at this. We have figure 211 shows two bar graphs depicting the life expectancies for men and women born in designated year. So then let's take a look at them. Okay. So take a look at the age scale in each of these, and then you can kind of see which one would be a better representation. Would you think the first graph or the second graph? Okay. So I don't know what all their data was. Obviously, we can have people that die at any age. So I would go with the second graph, but that's just based on the two graphs. I don't know what their data was. All right, the graphs are called clustered bar graphs because there are 2 bars for each year of birth. One bar represents the life expectancy for men, and the other represents the life expectancy for women. The height of each bar represents the life expectancy in years. Okay. An important feature is that of the changing scale. Notice that the scale between 0 and 65 is compressed. The changing scale amplifies the apparent difference between lifespans for men and women, as well as the increase in lifespans for those born in 1980 to the projected 2010. Okay, this is something that's important too. Whenever you change the scale in a graphic, warn the viewer by using this is actually a mathematical term, squiggle on the changed axis. Okay, so I don't know about you guys, but whenever I was in school, pretty much the majority of my schooling, I have always seen this. Okay, whether in a textbook or the professor or teacher at the chalkboard or the marker board or whatever you want to call it. And it can go in either direction. It doesn't have to always be the up direction. It can go on the axis on the bottom as well. But yes, that is the true mathematical terminology for it. It is called the squiggle. And the definition for it is so that you are warning someone that the scale has been altered in some way. Now, it is very important that you understand that the squiggle can only happen in the beginning. Okay, so you're not going to do like 5, 10, 15, 20, and then squiggle 100. Okay, you're not going to do that. If you need to use the squiggle, you do it at the beginning, and the whole purpose of it is to help you kind of reformat your scale. Now, I will tell you that I only use the squiggle if I can't go from 0 to a reasonable next number. So like if I'm counting by 20s, then 0 to 20 to me is fine, but I'm not going to go like 0 to 50. Okay, if I have to start at 50, then I'll use the squiggle. All right. Okay, Pareto charts. You want to pay attention here because just knowing from teaching it in the past, the Pareto chart is one of the harder charts for people. Hopefully we'll do a good job explaining it and you guys will be fine, but just want to give you the added statement there. So a Pareto chart is a bar graph in which the bar height represents frequencies of an event. In addition, the bars are arranged from left to right according to decreasing height. All right. And then basically it's saying here that another popular pictorial representation of data is a circle or pie chart. It is relatively safe for misinterpretation and especially useful for showing the division of total quantity into component parts. The total quantity of 100% is represented by the entire circle, with each wedge representing a component of the total. Okay. I didn't mean to do that. So proportional segments usually labeled with corresponding percentages of the total. In a circle graph or a pie chart, wedges of the circle visually display proportional parts of the total population that share the common characteristic. You have to use labels, okay? I know you might not like it. I know you're probably going to say, well, it's a math class, so I can just kind of be, you know, either taking like a lazy route or taking a like more succinct route. Your audience has to be able to understand what you're trying to tell them. So you can't just do a pie chart and then expect people to understand what you're trying to tell them and all you have for labels are your percentages. Like you telling me that you have a 25%, I can see that. I can see it's a quarter of the pie. What does the 25% mean? Okay, so that's something you will have to do when you do the practicing. A time series graph A time series graph is showing data measurements in chronological order. So to make a time series graph, we put on the horizontal scale and the variable being measured on the vertical. In a basic time series graph, we can connect the data points by line segments, okay? So it's kind of gonna look like an ogive, but a little bit, it'll be a little different. Oh my goodness. Mouse is making me so mad today. Okay. So this is saying, suppose you have been in the walking, jogging, exercise program for 20 weeks, and for each week you have recorded the distance you covered in 30 minutes. Your data log is shown below. So, okay, we have weeks 1 through 20. All right. And then we have the distances that correspond to each. It wants you to make a time series graph based on that data. So the data are appropriate for a time series graph because they represent the same measurement, distance covered in 30 minutes taken at different times. So if this would have told you that you have varying times, you would need to make it all consistent timing in order to do the chart. Does that make sense? Like you can't have one day they're measuring for 30 minutes and then the next day they're measuring for 2 hours. You can't do that, okay? It's not something that they can do. The measurements are also recorded at equal time intervals every week. To make our time series graph, we list the weeks in order on the horizontal scale. Above each week, we plot the distance covered on a vertical scale, okay? So do you kind of see how it's slightly like an ogive? All right. The difference between this and an ogive is that this has all the data points. The ogive only has the cumulative frequencies, okay? You guys will probably really want to do that table thing that I talked about last week, where you have like what the chart type is. You're going to want to have the chart type, like the name. You're going to want to have some features about it, and what, example of what one looks like. You really don't want to get this stuff confused because especially when we have our first test coming up soon, you don't want that added stress. All right. From looking at figure 214, can you detect any patterns? So let's go back to it. What can you guys tell me? In general.
That over the course of these weeks, people can run for longer periods or longer distances as the weeks go on.
Okay, so basically we would be seeing an increase in their endurance, right? So they're still only working out for 30 minutes, but you can see there's a significant difference between week 1 for 30 minutes and week 20 for 30 minutes, okay? They're starting to kind of increase that amount of distance that they can walk or jog in half an hour, okay? That's going to be for literally anyone, okay? Even if all you can do is walk, if you walk consistently for 20 weeks, you're going to increase your distance. You literally would have to be working against yourself to not have any kind of gain. All right, there seems to be an upward trend in distance covered, which we said. It does say here that distance covered in the last few weeks are about a mile farther than those in the first few weeks, which that just verifies what we said. However, you cannot conclude that the trend will continue. And that is true because we're only talking about half an hour. So you can't really predict if this individual will ever be able to exceed 2.5 miles in half an hour. Okay. I mean, if we had some more information, we can maybe determine that, but right now we just have that information and we can't predict the future for that. What we could say is that with continued exercise and half an hour measurements, then it would be reasonable to assume that they could plateau at 2.5 miles. Okay, so you would basically be able to say that in the future, this participant would walk at least 2.5 miles in a half an hour. Makes sense? So they could exceed it, but based on their data, they're at least going to walk 2.5 miles. Of course, they could also sprain their ankle next week and then be back down to like half a mile. So you never know. All right, data sets composed of similar measurements taken by regular time intervals are called time series. Time series are often used in economics, finance, sociology, medicine, and other situations in which we want to study or monitor a similar measure over a period of time. A time series graph can reveal some of the main features of a time series. Time series data consists of measurements of the same variable for the same subject taken at regular intervals over a period of time. So a lot of medical trials are going to be able to represent their data in a time series graph. All right. This you will want to go ahead and write down or like take a snippet or however you want to do it. This is going to help you try to decide what type of graph to use given different situations. This does not mean that you can't represent outside of these guidelines or suggestions. What it does mean is that, you know, if WebAssign tells you to do something, just, I hate to tell you guys to be sheep, but just do what WebAssign says because, you know, that's how you're going to get the points. For me, if you're going to do something and you would like to think outside the box or whatever the situation is, if I don't tell you specifically what to make, then just make whichever one you want. If it were me, I would make the one that I struggle with the most so I could get feedback from it. That's my personal thoughts. But yes, so I'm not going to read this to you guys because I think you guys can handle reading that on your own. Okay, this is the end of section 1.2. So are there any questions for 1.2? I lied. 2.2. Okay. Okay. These will be on, it'll be up